Look up at the night sky. For all of human history, that glittering canopy of stars defined the entire universe. But in the last century, our eyes have opened. Telescopes, sensitive to every wavelength of light, have revealed a cosmos of unimaginable scale and complexity. We've mapped the cosmic web, a sprawling structure of galaxy superclusters stretching for billions of light years, separated by vast, dark voids. We believed we had a decent picture of the grand architecture of reality. We thought the universe, on the largest scales, was basically the same everywhere. We were wrong. Because when we looked back to the very dawn of time, to the faint, residual glow of the Big Bang itself, we found something staring back at us. A patch of sky, a billion light-years across, that is profoundly, unnervingly cold. It's a gaping hole in our understanding of the cosmos, an anomaly so significant that it challenges the very foundations of what we know. To understand this mystery, you first have to understand the map on which it was found. It's called the Cosmic Microwave Background, or CMB. Think of it as the universe's baby picture. It's the oldest light in existence, an echo of the fiery explosion that started everything, released just 380,000 years after the Big Bang. This faint, microwave glow fills all of space, and it's remarkably uniform. The temperature of the CMB is almost the exact same everywhere you look, about 2.7 degrees above absolute zero. Almost. There are minuscule fluctuations in temperature, tiny hot and cold spots that represent the seeds from which all galaxies, stars, and planets would eventually grow. Our standard model of cosmology, the theory that so accurately describes the universe, predicted that these spots would be random, scattered across the sky like cosmic static. But in 2004, a satellite named WMAP was meticulously charting this ancient light, and it found something that wasn't supposed to be there. In the direction of the constellation Eridanus, it detected a region of the CMB that was abnormally large and abnormally cold. This wasn't a tiny fluctuation, it was a cosmic behemoth. The CMB cold spot, as it came to be known, is a staggering 1.8 billion light-years in diameter. If our own Milky Way galaxy were a single grain of sand, this cold spot would be the size of a football stadium. The odds of such a massive, cold feature appearing by pure chance in our standard model are less than 2%. Possible, yes, but unlikely enough to make astronomers deeply uncomfortable. Something had to be causing it. The most straightforward explanation is what's known as a supervoid. Imagine the universe is a giant, soapy foam. The walls of the bubbles are where the galaxies and galaxy clusters are, and the empty spaces inside the bubbles are voids. A supervoid is just an exceptionally large, exceptionally empty one of these bubbles. The theory goes like this. As a photon of light from the CMB travels through the cosmos, it passes through regions of matter. When it enters a supervoid, it has to climb out of the gravitational pull of the matter surrounding it, which causes it to lose a bit of energy and cool down. Ordinarily, as it leaves the void on the other side, it would regain that energy. But because the universe is expanding, the void itself has stretched out while the photon was inside. The journey out is now longer, and the gravitational pull is weaker. The photon can't regain all the energy it lost. The net effect is that it emerges slightly colder. A massive supervoid could, in theory, create a cold spot in the CMB. It's an elegant idea, and for a while, it seemed like the answer. Astronomers pointed their telescopes towards the cold spot, expecting to find a profound lack of galaxies. They did find a void. The problem is, it's not nearly empty enough. The Eridanus supervoid, as it's called, can only account for about 10% of the observed coldness. The void required to explain the anomaly would need to be deeper and emptier than anything we've ever seen or believe can exist. The simplest explanation just doesn't fit the facts. So if it's not a supervoid, and it's not just a statistical fluke, what is it? This is where the theories drift from the realm of astronomy into something far more profound and far stranger. One of the most tantalizing possibilities is that the cold spot is not an absence of something, but the presence of something else entirely. It could be a scar, a cosmic bruise left over from an ancient collision between our universe and another. This idea comes from string theory and the concept of the multiverse. which posits that our universe is just one bubble in a vast, frothing sea of other bubble universes. If our bubble bumped into another one in the distant past, the encounter would have sent ripples through spacetime, disrupting the energy of that region and leaving a permanent, cold imprint on our cosmic microwave background. The cold spot could be the first tangible piece of evidence that we are not alone, not just in our universe, but that our entire universe is not the only one. Is this great void merely an echo of emptiness, or is it the first faint whisper from a universe next door?